Okay, this is lesson 6.4, and this is the quadratic formula. Now, the quadratic formula is a formula that you can use to find the roots of a quadratic equation. We would use this when we can't factor to solve for the roots. So if we were given a question like example 1, and we tried to factor by looking for numbers that multiply to 10 and add to negative 7, and we couldn't factor it, we could then use this complicated looking formula. If we can factor, we should probably try to factor it. And if we can factor it, we should solve by factoring. But if we can't, we can use the quadratic formula. So, put a little star here. Use when quadratic is unfactorable. Now, of course, we could just use this whenever. It's usually just faster to factor to solve than it is to use this formula. However, you do have the option, if it says just solve, to use it whenever you'd like. So in example 1, it says use the quadratic formula to solve the equation. So it's asking us to use this formula, so it doesn't want us to solve by factoring. Even though we could solve this by factoring, we could look for the numbers that multiply to 10 and add to negative 7, and they exist, and we could solve by factoring. But we're not going to. We're going to try to use this new equation. So how do we use this equation? Well, let's inspect it first. We have x equals, so that means we're going to get our answers here, our x's. We've got negative b plus minus the square root of b squared minus 4ac, and that whole expression is divided by 2a. Notice there's a's, b's, and c's in this equation. The a's, b's, and c's come from the a, the b, and the c from standard form. So if we're using this to solve a quadratic, we have to have our quadratic in standard form. If we don't, we can just expand whatever form we're given to get to standard form. Fortunately, the two examples we're going to solve are in standard form already. So we need to be able to pick out the a, the b, and the c so we can use them in the equation. So the a is in front of the x squared. So in our equation here, the number in front of the x squared is 5. So 5 is our a. And negative 7 is in front of the x term. So that's our b. And 2 is on the end. That's our c. And now we have a, b, and c. So let's use the quadratic formula. Here we go. X equals negative b plus minus square root b squared minus 4ac divided by 2a. Let's fill in what we have. So we've got negative b to start. B is negative 7, so negative 7 would be positive 7. So we just have 7 plus or minus the square root. And b squared would be negative 7 squared. So I'm just going to write that, negative 7 squared minus 4 times a, which is 5, times c, which is 2, divided by 2 times a, which is 5. All right, so how do I usually solve this? Because we can't punch this whole thing in our calculator because we have this plus minus. Now, what the plus minus leads to is 2 answers, which is convenient because we can have 2 answers. We can also have 0 answers, and we could also have 1 answer, just like the ways that we could have that many numbers of x-intercepts. We could have 2 x-intercepts, 1 x-intercept, or 0 x-intercepts. So I'm going to show you later in the video where the other scenarios would come from, but for this example, we're going to get 2 answers. So how do I start solving? Well, if I'm doing it paper and pencil, I'm just going to leave the 7 plus minus, and 5 times 2 is something easy I can do, so I'm going to write it over 10. And what I'm going to do is I'm going to figure out what's under the square root here. Negative 7 squared is 49. 4 times 5 is 20, times 2 is 40, and we're subtracting. So our square root is the square root of 49 minus 40, which is 9. So we have this, 7 plus or minus the square root of 9, all divided by 10. And at this point, I would look to see if I could square root that number. And if I can nicely, like we can 9, we get 3, I would do it. So we get x equals 7 plus or minus 3 divided by 10. And now I just create two little equations. One with a plus sign, x equals 7 plus 3 divided by 10, and the other with the minus sign, 7 minus 3 divided by 10. And that's how the plus or minus works. Once you get to this simple expression, we write it with the two scenarios to get our two answers. 7 plus 3 is 10. 10 divided by 10 is 1. There's one answer. And 7 minus 3 is 4. 4 divided by 10 is just 2/5, or 0.4. And that's how we can use the quadratic equation to solve a quadratic. So what's the application of this? Well, the application is if we were doing a question like in 6.3 where we had the graph and we couldn't actually factor to find the x-intercepts. Now, this one we can factor to find the x-intercepts, but again, I picked this example just so the numbers work out kind of nice and we can actually come up with a graph. You can check your work by factoring if it's factorable, because there are numbers that multiply to -15 and add to -14. You might be able to guess what those numbers are and show that by factoring, but we're going to use the quadratic formula. So let's use the quadratic formula to find our x-intercepts, and then we'll find the axis of symmetry, the vertex, and draw a sketch. So we've got our A, our B, and our C. So let's use the quadratic formula. X equals, and it's negative B, so it's negative 14, which is just 14, plus or minus the square root of B squared, which would be negative 14 squared, minus 4 times A is 3, times C is -5, all divided by 2A, which is 3. Now we got to do a little bit of work. Let's get this number under the square root. 14 plus or minus, and 2 times 3 is 6. Let's find out what goes under our square root. So what I'm going to do is I'm just going to type in what's under the square root and come up with an answer. So we've got negative 14 squared minus 4 bracket 3 bracket negative 5. So underneath our square root we should end up with 256. And can we square root 256? Let's find out. 16. Awesome. So what we have is 14 plus or minus 16 over 6, which will lead to two answers. 14 plus 16 over 6, and 14 minus 16 over 6. The first one is 30 over 6, which gives us 5. And the next one would be negative 2 over 6, which is negative 1/3. Now, since this equation wasn't set equal to 0, these x's aren't roots, but they are x-intercepts. 5, 0, and negative 1/3, 0. So let's start a sketch with what we've got here. I'm going to use the bottom right-hand corner of my paper. And I'm not going to put a scale on it because it just says sketch, but I am going to label every point I put on my graph. So there's a dot for our -1/3, 0, our x-intercept, and here's another dot for my 5, 0 x-intercept. All right, we've got our x-intercepts on there. Next step is to find the axis of symmetry. To find the axis of symmetry, we add our x-intercepts and divide by 2. So 5 plus -1/3 divided by 2. So let's do that in the calculator. 5 plus -1/3 over 2. Get 7/3. So there's our axis. There's one x-intercept. There's two x-intercepts. 7/3 is like 2 1/3. So if 2 1/2 would be right in the middle. So let's just go a little bit to the right of that. Nice thing about a sketch is we don't really need a scale. We can just put everything on about where it should be. And if we want the vertex, we just have to take our 7/3 and put it into our equation. So let's do that. Y equals 3 7/3 squared minus 14 times 7/3 minus 5. And what do we get? Well, 3 bracket, let's put it over here, 7/3 squared minus 14 7/3 minus 5. And we get -64 over 3, which is a hard number to graph. -21 1/3 if we're going to approximate where it is on the graph. So that means our vertex is 7/3 and -64 over 3. And that's the last thing we need for our graph. So let's put that on here. I'm just going to put a dot down here. And that's our vertex, 7/3 and -64 over 3. And if we want to be really precise, we have a y-intercept as well, -5. So we could put that on about where it should be, which means that 1/3 away from our other x-intercept, we should have another point down here, which is also -5. And now we've got enough to draw a nice parabola. And there we have it. Y equals 3x squared minus 14x minus 5. So basically doing the exact same thing as we just did in the last lesson, but instead of factoring to solve, we use the quadratic formula to solve. All right, let's flip it over. So I said earlier in the lesson that we could have 1, 2, or 0 x-intercepts, and that's because of the discriminant. The discriminant is that part underneath the square root. And I'm going to show you how that plays in. And the way I'm going to do it is we're going to figure out what the discriminant is first, and then I'm going to show you how that impacts the quadratic equation. So if we look at the quadratic equation, if we remember, is x equals -b plus or minus the square root of b squared minus 4ac. So of the discriminant over 2a. So that part under the square root has a special name called the discriminant. And why it has a special name is because it tells you how many x-intercepts you're going to have. Let me show you how. So in our first equation, we have an a, a b, and a c. A is in front of the x squared, so it's 1. B is in front of the x, so it's 6. And c is the number at the end, so it's 5. If we figure out the discriminant using a, b, and c, we would get b is 6, so 6 squared minus 4 times 1 is a, and 5 is c. So what's that? Well, that's 36 minus 20, which is 16. So our discriminant is 16. And if we look at the quadratic formula, that would be x equals negative 6 plus or minus the square root of the discriminant, which is 16, over 2a, which is 2. If we solve this out, we're going to get two answers, which leads to the scenario of two x-intercepts. So either our parabola looks like this, opens up and the vertex is below, or it looks like this, opens down and the vertex is above. It all has to do with where the vertex is and which way the graph opens. But there are two x-intercepts. So this scenario is called when the discriminant is positive. So when the discriminant is greater than 0, we get two x-intercepts. So we're going to keep that conclusion. When the discriminant is positive, we get two x-intercepts. Get my colors prepared because we're going to have three scenarios. Scenario 2. We've got an a of 1 again, a b of negative 2, and a c of 1. Let's see what this does to the discriminant. B squared would be negative 2 squared minus 4 times a, which is 1, minus c, which is 1. Negative 2 squared is 4, minus 4 times 1 is 4. 4 minus 4 is 0. So in this scenario, the discriminant equals 0. Let's check back with our quadratic equation. The quadratic equation is negative b, so 2, plus or minus the square root of the discriminant, which we got as 0, divided by 2a, which is 2. So look what happens here. If we try to see our two answers, our first one is just 2 plus the square root of 0, which is 0, over 2, we get 1. In the second scenario, we have x equals 2 minus 0 over 2. 2 minus 0 is still 2, and 2 divided by 2 is 1. We get two answers, but if you look, the numbers are the same. They're the same two answers. So what that really means is we get one answer, which means we have only one x-intercept, and it's 1. So on our graph, we either have a parabola that starts here and goes up, or starts here and goes down. But what's key is the vertex is on the x-axis. So, scenario 2, if we get 0 for the discriminant, we have only one x-intercept. And it's because when you add or subtract 0, nothing changes. But when you add or subtract 4, you're going to get two different answers. Last scenario. How could there possibly be a last scenario? Well, let's consider this for a second. Positive discriminant, 0 discriminant. We haven't thought about a negative discriminant. So in this scenario, we're going to get a discriminant that's less than 0. Let's see what that leads to. Well, we got a, b, and c. A is 1, b is negative 3, c is 10. Let's find our discriminant. Negative b squared is negative 3 squared minus 4 times a is 1 times c is 10. Negative 3 squared is 9 minus 40 is negative 31. So our discriminant is negative. And let's see what happens. Well, our quadratic equation would be negative b, so 3 plus or minus the square root of negative 31 over 10. Not 10, 2. because it's 2a. Let's try to enter one of these in our calculator. Let's do the plus one. 3 plus the square root of negative 31. I have to put that whole thing in brackets. So I can do divide by 2. And then we get an error. Well, why do we get an error? The reason we get an error is because of this. You can't square root a negative. So no matter whether we're going to add or subtract the square root of negative 31, a negative number. Therefore, there's no solution. Since we can't square root a negative, there's no solution. So what's that mean? Well, on our graph, that just means we'll have a parabola that doesn't have any x-intercepts. Zero x-intercepts. What's that look like? Well, that looks like either when you have a vertex that's positive and has a minimum value, so our parabola opens up, or your parabola opens down and it's a maximum value. Those are your two scenarios when you have 0 x-intercepts. So the quadratic formula is quite powerful, but so is the discriminant. If you just use the b squared minus 4ac and you test all of your quadratic equations, you'll know how many answers you're going to get. All we need to be able to recognize here is that if we get the number under the square root to be positive, we're going to have 2 answers. If we get 0, there's 1 answer. And if we get negative, we're not going to be able to solve it. There's no answers. Now, if your equation is not in standard form, we can reason this out. A parabola has the equation x minus 2 squared plus 3. State the coordinates of the vertex, the direction of opening, and how many x-intercepts it has, and sketch the parabola. Well, we know first the vertex is 2, 3. So if I sketch that 2, 3, there's my vertex. The direction of opening comes from right there. Well, our parabola opens up. So if we start here and we open up, are we going to have any x-intercepts? No, we're not. So to figure out how many x-intercepts we're going to have if we're in vertex form, we just need to look at the vertex and the direction of opening, and it will tell us. And we can use our knowledge of the step pattern to come up with our sketch. Since we have a 1, we just have the normal step pattern. So over 1 up 1, over 1 up 3. And there's our parabola. So there we have it. Quadratic formula and the discriminant to figure out how many solutions we're going to have or how many x-intercepts we are going to have when we graph. Okay, that's it for lesson 6.4. I'll see you for our last lesson, 6.5.